Welcome to the NSTA STEM 2020 virtual event. Today, we hope to share with you two K-12 STEM programs, Big Data Analytics and Aerospace, that begin as a discussion in the hallway and develop into programs throughout the K-12 school setting.
We will go through our story about the framework for each of these programs and discuss its impact on students, and also discuss how these programs have expanded to other schools and beyond the walls to establish community partnerships. Hopefully, you will be able to take away some ideas about how you can start similar programs in your schools. So how are things with you today, Peter?
Pretty good. Yourself, Craig?
So let's go ahead and start off with some introductions here. All right, let me go ahead and introduce you guys to Dr. Peter Tong, AKA Batman, or sometimes Robin. We have a hard time determining who's the Batman and who's the Robin from time to time. Dr. Peter Tong pioneered the Big Data Analytics program for K-12 education, where neither curriculum nor standards existed. His passion in data analytics is evident in his teachings and research work. He shares his data analytics passion with his students by supervising practical data analytics projects in his Big Data Analytics course. Both his and his students' work have been presented regularly at several international Big Data Analytics conferences. Peter began his career as an aerospace engineer in the preliminary design of supersonic Mach 2+ UAVs for the development of National Defense Canada. He later found his calling to be a teacher with a background in electrical engineer, Master of Science in Mechanical Engineer, and a PhD in Aerospace Engineer. Along with a diploma in education, Peter readily integrates practical real-life education experience into the classroom. He also developed an engineering course for high school. He is a member of the program committee and has chaired conferences for the International Big Data and Analytics Educational Conference. He has taught in Australia, Canada, Indonesia, Malaysia, Singapore, and is currently teaching in China.
Craig, thanks for the introduction. Now let me introduce you to my co-presenter and esteemed colleague, Craig, AKA Batman. Again, we never know who's who. Craig, AKA Batman, has been teaching overseas on and off since 1999, working in Korea, Brazil, the United States, China, and Qatar. He has taught over 25+ years in elementary and middle schools. He has realized that educators need to seek out that spark inside each student that will engage them in a successful lifetime of learning. Most recently, he helped develop the STEAM electives in the middle school, co-directed the Qingqiao Mini Maker Fair in Shanghai for 4 years, assisted with the American School of Doha Maker Fair for 2 years, and presented middle school big data making and aerospace at conferences in China, Hawaii, and England. Craig was also one of the founders of the International Schools of Shanghai Area Schools FLL Robotics League, now a bilingual league recognized by FLL China. He believes that STEAM courses inspire students to ask questions, look for solutions, innovate, and create. Craig has an M.Ed in administration and an M.S. in science education, trained in design thinking by Stanford B School. So Craig, what are we sharing in this session?
Good question. All right, so Peter, you're going to briefly discuss the K-12 need for big data analytics in the high school program. You're also going to talk about the aerospace program and how to establish school and industry connections. And then somewhere in between here, I'm going to briefly discuss what big data analytics looks like in the elementary school and the middle school.
Please remember that this is only a brief overview of these two programs. We hope to entertain questions at the end of the presentation or through your emails. We want to share the details with you. Why is data so important? Here's why. This is a quote by Jeff Jonas, an acclaimed data scientist. This animation was created by a student, an example of how this course can be cross-disciplinary into arts and animation. Let the data speak. The need for data. Data is the natural resource to analytics. And here's the pipeline development. While universities have been offering undergraduate courses in big data alongside existing graduate courses, there is still a vast shortage of data scientists in comparison to the high demand of the current job market. The inability to meet this demand lies in the lack of a structured K-12 big data program that is fully able to prepare students with the proper set of critical thinking, inductive reasoning, and analytical skills required to form a conceptual understanding of big data and its applications in STEAM and liberal arts field. In trying to meet the demand of the job market, it is important that a proper development of analytics curriculum and program be constructed. Here's an illustration of the program development. In order to meet the objective, the path to meeting this goal is to begin from K-12. Hence, a more well-founded base foundation to support the undergraduate program is to be in place to upload the learning program structure. Got an idea? Tell your administrator, your supervisor, or the curriculum director. It will certainly help to have their support. But if this option is not available, create your own path. We'll give you some suggestions on how to proceed with this later in the presentation. The birth of big data analytics. What started out as a simple hallway conversation became a reality. Act on your dream. Make it a reality. Due to the accessible nature of big data in today's learning environment, where new subject matter and information are constantly evolving, the pedagogical value of big data provides an opportunity for a paradigm shift in teaching from sage on the stage to guided on the side, as coined by Alison King. Not only does this alternate teaching method create innovative opportunities for students to discover and to learn independently, it also enables students to develop the confidence to research and teach themselves in the future. The vision is to develop the big data analytics program from high school to elementary school. The challenge is bringing this concept to the younger students. From an introductory 2-week exploration high school course at Concordia International School, Shanghai, big data analytics has grown by student demand to a new elective course, the first big data course offered in international schools in Asia. With no established teaching resources, the delivery of big data as a student-centered course consisted of lecture styles, peer discussions, and practical learning through group and independent project work investigating the community, industry, and commercial sectors. The pioneering of big data analytics at Concordia, Shanghai confirms the stimulating and encouraging need for the specific development of big data in the K-12 program to enable an adaptable and progressive education for the future generation. Craig will discuss big data analytics in the elementary and middle school.
What data analytics looks like in the elementary school. The name of the program is called Mountains of Data. This is designed for elementary school grades 3 through 6. It is an 8 to 10 week journey in which students are exploring data around them. And we have it in the after school program. Elementary school, we have 3 goals. The 3 A's, awareness, appreciation, and application opportunities. Awareness. We start off with inviting a guest in. He discusses with the students a decade-long coral reef study that high school students have been conducting and all the data that they have been collecting. We have another activity called categorizing Legos, where students are given a pile of Legos and we ask them to make meaning of those Legos. They soon realize that individually the Legos are just random pieces of data with no meaning, but once they start categorizing and grouping those Legos, they actually have a story to tell. Then we have students go out into the natural environment around the school and they explore patterns in nature and collect data. And then we also have some biometrics activities, which they do. Then we move on to the appreciation part, which is making meaning through measurements and graphing. Here we have students graphing and comparing feet and hands. Here we have students graphing walking pulse versus resting pulse. And again, more graphs, more discussion, and talking about the data and talking about its meaning and personal connections with students and those around them. Then we move on to the application part. Here, students asked, is classroom lighting sufficient for optimal learning conditions? And so they used a vernier probe to go from classroom to classroom to measure the lighting conditions in those classrooms. And they realized that the general lighting was below the recommended levels for the different types of learning. Then they were able to present those findings to the elementary school administration that was in the process of remodeling those classrooms. Then we also had another application activity. What are the optimal playground surfaces? Students used an infrared gun and they collected data on which surfaces were the coolest to play on. They came back in as a group, they put their sticky notes out with all their data, and we discussed the data and made recommendations to the admin team the next time they remodel, what type of surfaces should they provide in the elementary school playground area. Again, being able to make recommendations to other groups based upon your data is very empowering to students. And where are we going to go next? Well, big data is my future. We want to develop a K-2 program. So I love this video. Big data is my future. Those are our future data scientists. All right, what I would like to do now is move on to a discussion of middle school. What does data analytics look like for middle school students? Again, we call it mountains of data. We want to make it personal in the middle school. And also we want students to explore how it can tell a story using visuals. All right, the middle school goals are also the 3 A's, awareness, appreciation, and application opportunities. And to begin our awareness, we have students create a survey and ask the question, am I a typical student? They send the survey out to all of their middle school peers. And when the data comes back, they analyze it to see how they fit the typical middle school student. And then we also look at what kind of data is collected from me, and they understand security cameras, browsers, social media apps. Many of them didn't realize all the free information they were giving out every time they downloaded an app to their phone. And then in the awareness part, they create posters from their learnings. And here are some zoomed in parts of their posters. They've got lots of quotes, lots of pieces of information here, a little bit about the digital footprint that lives on forever, and then the apps that are collecting data and everywhere else that is collecting data on them. And then we move to the appreciation part through visualization. I use Tableau, Excel, Google Charts, Plotly, Infogram, and Data Wrapper because they have free student accounts. I have Tableau highlighted because I recommend using that because it will actually do some more detail analysis, which the other programs don't necessarily do. And again, once they're doing this part, they're mining the data, they're organizing it, and they're cleaning the data, and then they're using these different programs to visualize the data in a unique way that tells their story. Then we move on to the application part. I start them collecting information, data on a personal topic of their choice at the very beginning. So by the time we get to this point in the class, they already have at least 4 to 5 weeks of data collected. And then they take that personal data they collected, like this one said, my sleep habits. They clean it, they go ahead and organize it into charts, and then they import that into a data visualization program, and they use that to help tell a story. Another part of this application piece, if you have time, do a class project. Here we have students measuring air quality indoors after vestibules were put in versus the air quality in areas indoors that did not have vestibules. Here we have students collecting data to determine the pond health of a local ecosystem and make recommendations to some park managers. Again, keep in mind, collecting data is sometimes very messy, but it can be very, very hands-on, and students can make really strong personal connections to that data. Now, I would like you to pass this on to Peter, who will next discuss big data analytics in high school and industry partnerships, and a little bit about the Aerospace STEM course. Peter?
The focus of this course is on the conceptual understanding and the application theory behind big data analytics, rather than explicit formulas and technical jargons. The main objective for this course is to create awareness and to be exposed to the realm of big data and the hidden dangers that it might bring. This course will include some hands-on experience utilizing big data analytics to solve some practical real-life projects. Focus of this course is on the conceptual understanding and application theory. This big data course was also offered as a distance learning program to our sister school in Hanoi, Vietnam, to help them kickstart the program. Students from both schools collaborated remotely via Skype. We collaborated with University of Derby on the location-based services project, researching on the accuracy of the location coordinates detected by the many different types of smartphones. Students carried out projects of their interest and presented their findings on short videos. This mode of assignment allows students to take their work with them even after they've completed the course. Some of the students' self-selected projects were presented at international big data conferences. Rio, who was personally affected by the Fukushima earthquake in 2011, carried out research on earthquake activities in Japan. Grace, through the lens of a student, helped develop the initial middle school big data program. Students also presented their big data research projects in Hawaii and in the UK. We also hosted one of the international big data EdCon conferences at our school. In the quest for data, we embarked on the Internet of Things, IoT, where teachers and students built air quality sensors and built a data warehouse repository. The sensors were extensively tested, calibrated, and corrected with commercial-grade CO2 and PM2.5 sensors at Honeywell's Air Sensors Lab. The curves for CO2 were obtained through documented protocol. These sensors are deployed around the campus to continuously collect data. We would also like to invite schools around the world to join us on this big global data analytics program on global data collections and on sharing of data. Athena taught herself IBM Cognos Analytics, a software she used to perform analytics on her research project. She created short video tutorials on IBM Cognos Analytics. This course caters for students of all interests, not just STEM, but STEAM. Daisy, with her artistic skills, created a big data analytics picture book for young children. The student who helped develop this course at our high school in 2014 took the skills he acquired and made it bigger. He instigated and helped pioneer the big data analytics program at UC Berkeley and graduated top of his class. No surprise there. On establishing partnerships, this will bring in corporate partnerships as well. Baidu assisted one of our students' video analytics project. Cheon provided our students with blockchain exposures. VMware provided internships for our students. IBM supported us with academic licenses, technical support, and professional advice. A medical hospital in Hanoi collaborated on our health research project. We have even attracted a huge sum of donations from the community to support the AQI project and to further develop our big data analytics education program. 4 of our students are in the process of launching their own big data analytics.com company. Another group of students are developing some big data analytics program for the community. Craig, can you tell us about the aerospace program?
Yeah, briefly. Well, some of the topics in the projects we cover in the high school, and some of it bleeds down into the middle school engineering program. Talk about, we model building. So we do free flight with balsa wood planes. We do power flight with balsa wood planes. And we do airfoil design, rocketry, RC drones, and flight simulator. This picture here shows some of our high school students modeling their free flight balsa wood planes and talking a little bit about the aerodynamics and questioning each other whether or not and how far their plane will actually fly. This is some of the components that we use in the middle school. We've got our power anchor here hooked up to a power source. We put motors towards the front here. We've got the guides that can show you how to do this. Sometimes we also like to introduce new variables. So what will happen to the speed of the plane and the lift of the plane if you actually add weight to it? Again, here's some of our high school students building their planes, and this is them building their powered flight balsa wood planes. Now let me show you a little bit about the power anchor. Here's the power anchor, and we use this mainly in the middle school and high school to test the behavior of flight. So once the students have made their powered balsa wood planes, then they hook it up to this and test it. And this is what it looks like, and I apologize for the lag. Again, a lot of fun. But we can also tell you more about how you use this to actually analyze the behavior of flight. Now, one fun activity is, because you can hook up 2 planes at a time and you can control the power level of each of the planes, we take a piece of toilet paper, we put onto the back of the plane, and then we try to have one plane come around and see if it can actually eat up that toilet paper. Very, very good tool for analyzing the behavior of flight. Peter, do you want to take us through the next slide?
Sure.
Here?
Students gain understanding of airfoil by designing them and testing them using styrofoam blocks. The students also researched and built their very own drones. This space could have been mistaken as a drone production facility. The students also explored their drone building skills creativity. Shown here is where a student implemented the landing gear system to his drone, which can easily be converted onto a claw for picking up packages. Samuel, with his interest in 3D printing, developed a modular drone. Students also explored rocketry. As the world was caught off guard in February due to COVID-19, our school had to implement home-based learning. Students carried out projects on how COVID-19 are affecting the aerospace and airline industries and created short videos on their findings. Another example on how students can benefit long-term with their hard work assignments. Students built non-motion flight simulators to gain simulated flying experience. They also have access to an FAA-approved 6 degrees of freedom flight simulator. We also partner with the local aerospace industry who gave our students simulation time on a 6 degrees of freedom flight simulator. Delta gave us a tour of their facilities at the Pudong Airport, Shanghai. Our local aerospace contact provided us access to the Asian Business Aviation Conference and exhibition, where students visited the interior of some of the private jets. Very lucky. GE Aviation Shanghai gave us a tour of their GE engine facilities, where students had some hands-on experience on the engine turbines. Textron Aviation gave us a tour of their aircraft assembly and service facility. Students were given hands-on experience to better understand how airplanes operate. Here are some of the resources to this course.
At this point, we look forward to entertaining any of your questions in the Q&A session. Thanks for listening. We'll see you soon.
Thank you.